So here we're taking a look at an example of calculating the cell potential of an electrolytic cell. With an electrolytic cell, all we're taking a look at, or the only difference, is that instead of a voltaic cell where we have the terminals connected for the negative going to the anode and the positive going to the cathode, we're just switching that and then adding in a power source. So let's just grab the pen's ready. Okay, so to begin with, it does say electrolytic. That does imply your cell potential will be less than 0 because you're going to have a non-spontaneous reaction. So we want to figure out first what is present. You have aqueous copper 2 bromide. So copper 2 bromide would look like this, and if it's aqueous, then what's present here would be copper 2 positive, bromide ions, and water. So if this is what's present, then you want to start to take a look at what are your OAs, what's your RAs. Copper 2 positive is an OA, bromine negative is an RA, and water, as we know, is both. So now we'll look for our strongest OA, strongest RA. So copper 2 positive will be our strongest OA. So this undergoes reduction, happens at the cathode, and we can grab that value. The value here is 0.34 volts. Then looking at your strongest RA, bromine appears first on the bottom right before water. So the bromine ion would be our strongest RA. RAs undergo oxidation. That happens at the anode. And that value from your data booklet is positive 1.07. So if you want to figure out the E of the cell, it's always going to be the cell potential of the cathode minus your cell potential of the anode. So let's fill in those values, 0.34 volts minus positive 1.07, and just putting that in to my calculator, you get negative 0.73 volts. So this makes sense because it's electrolytic. Electrolytic should have a negative value, and it adds in that note here. That means the reaction is non-spontaneous. So even looking at your table, your RA would be above your OA. And then oftentimes with this type of question, it will ask you the minimum potential you have to put in to drive the reaction. So we would have to put in at least positive 0.73 volts of electricity just to make this reaction start to work. So we add in this electricity, and then we can get out our chemical reaction. And if you found this video helpful, please subscribe. If you would like me to do any other type of example, please say so in the comments. Thank you.